proteins. The monomer of proteins are amino acid. So the monomers of the proteins are amino acid. To review the amino acid group, on the left hand side we have the amine group, and on the right hand side we have the carboxyl group, which is the C and the 2O and the H. And on the bottom we have the R group. In biology, the R group represents anything. Just like in math, X is the variable. Biology scientists prefer to use the letter R. When many amino acids are put together, it becomes a polymer called polypeptide. There are 20 known amino acids. So just a quick review, there is the amine group, the carboxyl group, and the R group. That's what makes up an amino acid. Now we trace back to carbohydrate. In a dimer, the bond, the link between the two monosaccharide is called a glycosidic linkage. For protein, when amino acids bond, in between them, it's called a peptide bond. On the left hand side, we see is an amino acid. Over here it's another one, and when they bond together, becomes a peptide bond. Now notice that water was removed in order to create the peptide bond. Water was removed. What was the name of the process called again when you remove water in order to put two things together? Dehydration synthesis. Putting things together by removing water. Saturated fat. So we learned that saturated fat is bad for you, and unsaturated fat is not bad for you. It's okay, sometimes good. Now let's learn why. So unsaturated fat at room temperature are liquid, like this oil right here. It doesn't usually solidify at room temperature, so that's a good thing. So when you eat a lot of unsaturated fat instead of saturated, your membrane, which is made out of lipid, tends to not solidify. Let's learn why. Over here we have two saturated tails with lots of H, and an unsaturated down here has a double bond, which creates a kink. Over here, the saturated, as you can see, they're neatly held tight together. So that's why it's easy to solidify at room temperature. Whereas for the double bond, because of the kink, the cell membrane is more fluid. It doesn't easily solidify. Well, isn't oil bad for you? Depends, some oil are good and some are bad. The good oil, it starts in a cis form. And then if you start to cook too long, it transforms into a trans form. Get it? It transform a trans. Okay, anyways, moving on. So trans are bad for you. Haven't we heard that word somewhere before? We heard it in trans fat. And as you have heard, trans fat can be bad for you. So the question is, how do you get from cis form into a trans form? Well, let's start with cooking at home. When your parents cook, they usually do not reuse the oil. The reason being is when you cook, it looks greasy and liquid. It looks okay, not as bad, but the moment it's too solidified, it starts to look very greasy and gross. So besides the fact that it looks gross, you don't want to put that into your throat, it's not good for you. At fast food restaurant, however, that's not the case. They reuse the oil many times, such as cooking the French fries. The reason is they save themselves a lot of money. And because they save themselves a lot of money, the food costs less. So it's good for you because you're not spending as much money on food at fast food restaurant, but you're exchanging your health in return. So good oil turns bad because you reuse many times. The more you reuse, the more cis turns into trans. Now let's learn how and why. What happened is the double bond gets broken up in the unsaturated. So then it turns into saturated, which is back into the form that easily solidify at room temperature. In your cell membrane, composed of lipids, if you have consumed too much saturated fat, will easily solidify at room temperature, which increases the chance of heart attack. So now we learn why fast food is bad for you. We learn how it's bad for you. So spread the word. We know it's bad, but it can get pretty serious. Number one death in America is heart attack. So if you really care about yourself and the people around you, try to stay away from fast food. So, what's for dinner?